Hi everyone, we're going to be talking about some periodic trends. You'll want to bring out your periodic table because we're going to be marking it up today. So first of all, we want to think about atomic size. So anytime you are thinking about how big an atom is, yes, they're all really tiny. However, some of them are smaller than others. So the distance between the nucleus, remember our nucleus is the thing that has the protons and the neutrons, is going to estimate the size of an atom. So the atomic radius is typically half the distance between the two nuclei. So if you think about the whole distance between our two nuclei, that would be, you only want half of it. So right down the middle, you only want half of it because that'll tell us the radius. And remember from math class, the radius is the distance from the center of a circle all the way out to the outer edge. So anytime you are looking at an atomic size, it's actually going to be the radius of an atom. So the distance between two nuclei is typically very small. You will not have to calculate it. However, this is just going to give you the idea of how big a radius is. So between these two nuclei right here is about 2.8 times 10 to the negative 10th meters, so very small. And we want just the radius, so we just want half of this total distance. So if you were to take 280 divided by 2, that would give us our 140 times, or 1.40 times 10 to the negative 10th meters as our radius. So typically there are some trends that the atomic size will follow as you go along the periodic table. So if you have your periodic table out in front of you and you start at lithium, lithium is going to be the absolute biggest in that whole entire row. As you go from left to right, you're going to start to decrease in size. So as you go from left to right, the atomic radius is going to decrease. Now, if you start to go if you go down one period, so you've gone all the way across, you've hit neon, and now you're going to start back over in sodium. Sodium's actually going to be even bigger than our lithium. So as you go from top to bottom of our periodic table, the atomic radius is going to get bigger. Additionally, again, the same idea is true. As you go from left to right in the same row, your atomic radius is going to decrease, and you can see that on this graph. So overall, if you wanted to grab your periodic table, look something like this, and I would draw an arrow. So from left to right, your atomic radius is going to go up. So your atomic radius is decreasing, sorry about that. And as you go from top down to bottom, your atomic radius is going to increase. So the reason for this increase as you go from top to bottom is there is an increase in positive charge. Now remember, as you go from the top of our periodic table down to the bottom, your atomic number is going to increase. And that atomic number is telling you the number of your protons. So all of those things are telling you that your positive charge is going to get bigger and bigger. So if you have more protons pulling on those electrons, you're going to start to have something called shielding take effect. Shielding is essentially the number of electrons on the outermost energy levels are going to kind of be protected from that pull of the protons of the nucleus. So they're able to kind of explore a little bit more often. So it's going to result in an atomic size that gets a little bit larger. And that is shown in this, this graph as well. It looks very similar as the one that we've seen previously. So across the period, the electrons are added to the same principal energy level. So there's no shielding taking place as you go from left to right, meaning that the elements are going to start getting smaller as you go from left to right, but larger as you go from top to bottom. So you can see that is summarized right here in this picture. If you need to, take the time and pause the video and make sure that you have written that the size generally decreases as you go from left to right and how the size generally increases from top to bottom. Make sure you put that on your periodic table. Now, some compounds are composed of something called an ion. And an ion is simply an atom or a group of atoms that has a charge. The charge can be positive or negative. And the way that that happens is if a neutral atom is going to lose electrons. So for example, normally our sodium is going to have 11 positively charged protons and 11 negatively charged electrons. So if you had 11 positives and 11 negatives and you added those together, you would have a net charge of 0. However, if you were to lose one electron, okay, so you start out, you have to lose that one electron, you now have still 11 positives, but you only have 10 negatives. So overall, you would have a positive 1 charge. And that leads us to our first ion. There are things called cations, and those are our positively charged ions. And the way that I remember this is from the following picture that my science teacher told me. Picture, you have a cat. Yes, it's not really well drawn, but you have a cat that has positive eyes. So a cation must be something that has a positive charge. So we've already seen that in our sodium. Now there are some things that are negative ions, and that occurs by gaining electrons. So one example here is chlorine. We start out with 17 pluses, 17 protons, and we have 17 electrons because atoms are always neutral, giving us that 0 charge. Now, if you were to gain 1 electron, you would then still have your 17 positives. This part is not going to change. But you start to have more negatives. So if you were to add 17 to negative 18, you would end up with a negative 1. And that's how we get that charge on chlorine. Anytime you have a negative charge, you get an anion. And the way that my science teacher told me to remember them is from the following. Here's my terribly drawn ant, and those ants are bad. So the eyes of the ants are negative, so these are your anions. And those charge again are negatives, and you can see that in the eye. Now this only occurs during a reaction between metals and nonmetals. And if you want a reminder, your periodic table looks something like that. And you have your stair steps to kind of separate the two. On the left side, you have your metals, and on the right side, you have your nonmetals. So anytime you have something from the left and something from the right, you're going to produce some sort of ion. It's typically very predictable, and the size change is always the same. So cations, so remember those are our positive guys, are always smaller because remember we're losing something. It's kind of like if you were to take off your backpack, you become smaller. And anions, those are our negative guys. They're always going to be getting larger because you're gaining those electrons. Think of putting on extra backpacks. That's not fun. So you're going to get bigger. And you can kind of see that here. As you start to lose electrons, as you're going, this is down our first group on our periodic table, you are smaller than the neutral atom on the left, but as you go down, your size increases. So it follows the same trend as our atomic radius. So that same trend again. Now let's take a look at the other side whenever you're gaining electrons. So unlike the other one, your neutral atom is much smaller on the left. And after it has gained an electron, you can see that from the negative, you're going to start to get larger. And as you go down the same group, so this is group 7A, or I think 17 on your periodic table, you're going to continue to get larger again. And that is the exact same trend that you see for atomic radius. Now, from left to right, so you're going across the period, there are some visible trends, but they are going to be separated based on if it is a metal or a non-metal. So as you go from left to right above your metals, you're going to start to see a gradual decrease in the size. So again, a decrease in size. Once you go into the non-metal portion, as you're going from left to right, you're going to see again that decrease in size that you've seen before. Now remember that on the left side we're going to be becoming positive, so take a look here, and on the right side we are turning negative. So if you need a summary of that, we have this picture right here from your notes. Make sure that you add this to your periodic table. What I like to do is I like to use different colors for these different arrows to help me remember. Comes trend number 3. This trend is called the ionization energy. Now remember back to the fire demonstration where electrons can move to higher energy levels whenever it absorbs heat. Sometimes that's enough energy that it can overcome the attraction of the protons in the nucleus and actually leave the atom. So the ionization energy, here's a good new term for you to write down, is the energy required to remove an electron from an atom. And it follows the following trend. As you go from left to right, the energy required to remove that electron is going to increase. However, as you go down, your energy required to remove that first electron is going to generally decrease. The reason for that difference is the size of the atom. So as the size of an atom increases, the nucleus is going to have less effect on the electrons. So it's going to make it easier to remove. And you can see that on the left side over here as the energy generally decreases. However, as you go from left to right, remember we're getting smaller, so we know exactly where all of our electrons are, and it's going to make it tougher to remove. Finally, our last trend is electronegativity. Electronegativity is kind of the opposite of the ionization energy. Remember that ionization energy is removing an electron. Electronegativity is the ability of an atom to attract electrons. And there's actually some specific values that we found and calculated. However, you can take a look at those on your own time. However, in general, the electronegativity are going to decrease from top to bottom. So if you have your periodic table in front of you, as you go from top to bottom, it's going to decrease. And as you go from left to right, you're going to increase that electronegativity. So this last picture is a nice summary of all of the trends that we talked about today. I'd make sure that you have all of these in your notes. These are important because on a quiz or a test, these are great questions to ask what happens and how they're related to each other based on different atoms. As always, there are some great key facts at the very end, as well as some information on the vocabs from this section. All right, I'll see you tomorrow.